Hello students, good morning to all of you. Students, our today's topic is Astronomical Telescope. Okay, it is a device which is used to see far away object. Okay, very clearly. Its principle is similar to the compound microscope, but there is one difference between them. Like in compound microscope, the two lenses, one is objective lens and second is eye lens, is placed coaxially, in which objective lens of less or small focal length and eye lens is of large focal length. Okay, here in compound astronomical telescope, the objective is a bigger focal length and eye lens is smaller focal length. Okay, and similarly they are placed in a tube at a certain distance. Okay, now the figure for this. Objective lens, and eye lens. As we see by diagram. Okay, so it can be formed the image at two places. One is at infinity and second is at least distance of distinct medium. Okay, so initially we have formed this for the infinity. Okay, so in this case, because the object is very far away, so all the rays coming from the object towards this telescope are taken as parallel to each other, and for the spatial arrangement, or we say for the normal arrangement, the rays coming to it not parallel to the principal axis of the coaxial lenses. Okay, they are parallel to each other but not parallel to the principal axis. So here I will give you an idea that if this is the focal length and two or many rays traveling parallel to the principal axis of the lens, after reflection they intersect each other at point of focus. Okay, but if two or more rays which are not traveling parallel to the principal axis but parallel to each other like this, then what is the rule for it? So answer is they converge at the point of focal plane. Okay, like this. So when we draw a perpendicular on principal axis, we find it intersect at F. So this line X, Y is called focal plane. Okay, now similarly here when the rays coming parallel to each other but not parallel to the principal focus or principal axis, so they are taken as let's say we have these three rays in which what ray is traveling from optical center of objective lens. Okay, so it will move without deviation. Clear? Okay, which is not passing from the optical center but parallel to each other after reflection intersect each other at this point. And the third ray which is coming parallel to the other after reflection passing from the same. Okay, so this is the point of intersection all three rays which are coming parallel to the principal axis to the objective lens of telescope. Okay, then this is, suppose an object is placed at infinity and the rays coming from point A, so A dash and this B dash is image of the object at infinity. Okay, now if this point is location of focal length of focus point of objective and this is the location of FT, which means focus of FT. Okay, which means this is FT and from here to this point is F4, focal length of objective and this. Now, the next image which is formed in between the focal length of eyepiece and optical center of eyepiece. Then the image formed by this eye lens of the object A dash B dash is, let's see, after reflection they are moving in such a way that they all are parallel to each other, and an observer which is observing these rays, so all the rays are parallel to each other as arrangement. Okay, so it is very clear the image formed by this normal situation is formed at infinity also. Okay, now if this is the angle formed by image at eyepiece, let's say beta, clear? Next, and this is the angle formed by object at optical center of objective lens, and because this angle is alpha and this is vertical opposite to it, so this angle is alpha which is formed at eye by the object. Okay, therefore magnification of telescope, right? Magnification of telescope is the ratio of magnification of telescope is the ratio of angle formed by object, angle subtended by image at eye to angle subtended by object at eye, that is beta upon alpha. Okay, now we can calculate that beta is equal to tan beta and alpha is equal to tan alpha. Okay, now see, this is triangle 1. This is triangle 1 and this is C2 and triangle 2. Okay, so tan alpha, tan beta is in triangle A dash B dash C2, A dash B dash C2. What you get from here? So perpendicular A dash B dash upon this C2 B dash, C2 B dash, okay, and tan alpha is A dash B dash upon C1 B dash. Clear? Now, therefore magnification is equal to beta, which is A dash B dash upon C2 B dash into this we take 1 upon alpha, so C1 B dash upon A dash B. Clear? Then it will be cancelled and we get the result is equal to C1 B dash upon C2 B dash. Okay? Now, according to figure, C1 B dash is equal to FO. Okay, and C2 B dash is equal to FP or nearly equal to FP because the focal length of eyepiece is too small. Okay, therefore this result gives you idea or value FO upon FP. Okay, and because FE is left to the objective, so it is negative, you can also write it FO upon mod of minus FE. This is magnifying power of telescope for normal situation. Okay, right here. This is magnifying power of telescope for normal arrangement. For normal arrangement and for normal situation, image formed at infinity, image formed at infinity Okay, next. This is case 1. Case 1 for normal situation. Normal element. Okay. Now second is case 2 when image formed at least distance of distinct figure. Least distance of distinct figure. How much is the least distance? It is equal to D, and this is the location of V. Okay. So we are using V is equal to minus. Okay. The element for this is objective lens. This is eyepiece, and then these are the C1 and C2 optical sector of the two lenses, and the ray which is parallel to each other fall on the objective lens. Then after refraction, one ray which is traveling without deviation because it is passing from the optical center as per rule, one which is parallel to it but not passing from okay, then it will be passing from this point, and the another ray is also traveling from the same point. Therefore, this is the value of A dash B dash. Okay, now this ray after refraction goes deviated. This ray are moving but not parallel to each other after refraction. So, an observer can see all the rays, then one is traveling here, another is intersect at this point, and the last one is also passing through this point. Therefore, this is the image formed A double dash B double dash by the eyepiece, which is at the least distance of real ray. Now, if the distance between the two lenses is D, okay, so this is equal to VE this distance is equal to FO FE, this is FO. So this distance is equal to UE, okay, and object is initially at infinity. Okay, now when we join A dash with center, then this angle is angle subtended by the object because the ray is also passing from this point. Okay, so this is beta is the angle formed by the final image formed at A dash B A dash A double dash B double dash is equal to beta, and this is alpha, so this is also alpha. Therefore, this angle is angle subtended on I by the object. Okay, now magnifying power is beta upon alpha. From here we can calculate beta is equal to 10 beta and alpha is equal to 10 alpha, which is again from the figure A dash B dash upon distance C1 B dash, clear? C1 B dash, and this value is A dash B dash upon C2 B dash. Okay, the same value for objective we are calculating here. Okay, so from here what you get from alpha, which is equal to C1 B B dash equal to C2 B dash. This is the first condition. Secondly, when the two lenses placed coaxially, then their magnifying power is equal to the product of magnifying power of each lens. That is, M is equal to magnification produced by objective into magnification produced by eyepiece. Okay? Now, magnification produced by eyepiece is equal to distance of image to distance of object. Okay? This we get distance of image is FO upon FE. Clear? This is first equation. And second, 1 minute. Okay, 1 minute. This we get finally, na?
C2 B dash 1 C1 B dash 1.
1 minute. Where?
M equal to C1 B dash C2 B dash होता है.
C2 B dash.
2 ऊपर नीचे होगा. 35.
Opposite होना चाहिए ना? Okay. Yes. First we will see this. Beta C2, which means C2 B dash in numerator we have value of tan beta is A dash B dash upon C2 B dash. Same C2 B dash. We are solving this for the final limit. This will be taken as the same value C2 B dash and this is C1. Okay. Now what you get from here? Magnification is equal to A dash B dash, value of tan beta is C2 B dash into alpha opposite करेंगे C1 B dash and A double dash B double dash. Now this is cancelled and we get the magnification is equal to C1 B dash upon C2 B dash. Okay. Now C1 B dash is equal to FO is FO and how much is the value of C2 B dash? So answer is UB and it is in front of this is the value of U. Okay, now according to the lens formula for eyepiece, lens formula for eye lens. What we get? 1 upon Fe is equal to 1 upon V minus 1 upon U. Okay? Now, minus 1 upon UP is equal to 1 upon V minus 1 upon Fe. It is clear? Okay? Now take UV as common. VE as common. What we get? 1 upon VE 1 minus VE upon FE. Clear? Now we are considered here VE is equal to small d. Okay, therefore minus 1 upon UV is equal to 1 upon
So 1 upon UV positive.
huh?
So 1 upon UV positive.
Okay, yes.
So 1 upon UV left hand side here positive होगा. So 1 upon FE negative हो जाता है.
No, हमने सी इस वाली लाइन को दिस लाइन जस्ट सी अगेन 1 upon FE minus 1 upon VE equal to minus 1 upon UV. Okay, 1 upon UV is at right side and 1 upon VE is substitute to the left side. The result should be negative. So just calculate from this point. Let's say this is equation first. Solve value of equation first for 1 upon UV only, and then tell me what is the answer. Okay. Are you going for? See, we have 1 upon FE is equal to 1 upon VE minus 1 upon UV. Okay? Yes. So, this is 1 upon FE. Okay? This value is minus D. And this is UV. UV is in negative direction. Minus UV. Okay. Now this will substitute here 1 upon FE plus 1 upon V equal to minus minus plus is 1 upon UV. Then 1 upon FE is common. 1 plus FE upon V
So minus
is equal to 1 upon UV. Okay, clear? I think in the previous solution we are not using UE as minus. Okay, so because of that the result should be positive. But when we use this, here is result is negative because we are not using UE as negative. Okay, so if we are using UE as negative, so this result should be positive. Okay, therefore we get 1 upon UV is equal to 1 upon FE in bracket 1 plus FE upon D. So our problem is clear, and we can also write this relation as M is equal to F naught mod of negative FE 1 plus FE upon D. Okay, the result is similar to the compound microscope, but if you have remembered that in compound microscope the same formula, but D is numerator and FE as a denominator. There is a difference between them. Yes?
minus for whole ना.
Where?
So this is one करके मैं कुछ इनको.
Yes?
So step पर दे. तब वो minus FO upon FE पूरा whole में आ गया तो.
And it means this minus you have multiplied inside.
No sir.
Yes.
Sir, minus FO upon FE upon D plus 1. So minus दिखाना इसको किधर गया इसको किधर लेके minus number common minus D minus 1 and अपन FE को करके लेना.
Okay, wait. if you find the calculation in length formula for IP, so Fe is positive because focal length of convex. Clear? Now UE is negative. Why UE is negative? Because in front of IP. Clear? Clear? The answer. Next, VE. As per condition, the image formed at least distance of clear vision or distinct vision, which is VE is equal to minus D. This will use here minus D. Clear? Now, by putting all these values, 1 upon Fe is equal to 1 upon minus D and this. Now, this minus multiplied with this will become positive. We are using here is positive. And this 1 upon minus D substitute the left side, this will become positive. On solving this, we get this result only. Okay? So, we get 1 upon UE is equal to 1 upon Fe in bracket 1 plus Fe upon D. Okay, now by using this value in the magnification formula, 1 upon UE, the result should be F0 upon minus Fe in bracket 1 plus Fe upon D. Clear? This is the situation. Okay. So, because the object is very far away, okay, so when the image formed by the telescope of an faraway star or other things, these are having some defects because of lens defect. Okay, like that I am showing you which kind of defect observed by. It is okay. Very simple concept is this. As we have discussed earlier, okay, for observation, here when the light falls on the prism, then they suffer reflection, and as you all know that the image formed by the when the white light is fall on the prism, then it will be splitted into the constituent color. Okay, so the light coming from the star or the sun, as we all know, it is white light and they have all the colors of white light. So they are form of pattern. So there should be a different color in the point. So this is also, as at the time of lens, we can divide our convex lens in the parts. So this portion is behave like a prism. This portion is behave like again not parallel slab, but this is parallel slab. Clear? And again this value is not parallel, so it is inverted prism. This is inverted trapezium, and this is slab. So a light which is traveling from this point, see, if the light is traveling from here, then it has ability to contract the light with the maximum power of accommodation. So it will be contracted at this point. The light which is coming from here, it has less contracting power. So this light is weak at this point. Okay, and similarly, a light which is here, it has few or very less power of conversion. So this light is weak at this. So we have 3 points of image for this. Clear or not? So actual image of object is where? So answer is we cannot define, but because of this special structure of a convex lens or objective, the image has some blurriness. Okay, which means image you can able to see, but not clear. Okay, this is resolved by the resolving power of the telescope. But for this session, resolving power is cancelled or deleted. So this special error, which is due to its spherical shape, is called spherical aberration. Okay, this is first defect. And second, because it behaves like a small prism at different sections, 1, 2, 3, 4, 5 sections, and all 5 sections behave a differently. But initial are behaving like a prism. And you all know, when the white light is traveling from a prism, then it will be split into its constituent color. So there should be a color defect in the image form, that is chromatic aberration, chromatic for color. So there should be a color defect. So this will be resolved by using very large objective lens and eye lens, and with the same situation, objective of bigger focal length and eyepiece of small. But if we are doing so we have a very big telescopes which is not able to focus on the star because of its heavy weight. So we are using the different kind of telescope, which is called reflecting telescope. Reflecting, which means there should be an arrangement related to the mirror. The light coming from the star first reflect by a spherical reflector, and then they are fall on the plane mirror and then come to the eye of the observer. Then there's all errors should be corrected, and this special telescope, which is newly formed telescope, is called reflecting type telescope, or also known as Cassegrain telescope. How it is formed? So it is like this. It is fully concave. Okay, and suppose there is a star. Okay, from here the light coming parallel to each other. What happens after that? Follow the law of reflection, and there should be an element of plane mirror. This also falling here. Okay, and then after they reflect, and here is an object. All the rays are entering in his eyes, and there should be the formation of image. Then he will able to see the object very clearly, and these are formed at very small location, or we can say compact form. You can form these reflecting type telescope. Okay, so you will learn about it, and the magnification is for this m is equal to f. We have beta upon alpha, which is initial case, that we have f0 upon minus ft. Here f0 is very few curvature, and we can write it m is equal to f0 for the curvature of this spherical mirror, which is r by 2 of objective, and this is ft. This is the magnifying power of a Cassegrain telescope. Okay, so here the ray optics of class 12 physics unit 6 is completed. We will do some numerical related to the same, and in the next class we will discuss about the wave optics. Thank you.